Question number 2. Consider an open economy with 3 industries: coal mining operation, electricity generating plant, and an auto manufacturing plant. To produce $1 of coal, the mining operation must purchase 10 cents of its own production, 30 cents of electricity, and 10 cents worth of automobile for its transportation. To produce $1 of electricity, it takes 25 cents of coal, 40 cents of electricity, and 15 cents of automobile. Finally, to produce $1 worth of automobile, the auto manufacturing plant must purchase 20 cents of coal, 50 cents of electricity, and consume 10 cents of automobile. Assume also that during a period of 1 week, the economy has an exterior demand of $50,000 worth of coal, $75,000 worth of electricity, and $125,000 worth of autos. Let's suppose that equation for production, parentheses, output, is given by P equals the quantity I minus A inverse times D, where A is the coefficient matrix having each sector's purchase as column entries and D is the demand vector. I is the corresponding n times n square matrix. Find the production level of each of the 3 industries in that period of 1 week in order to exactly satisfy both the internal and external demands. The first step in any equation is to identify the variables in the equation that's given to you, or identify everything that's just given to you. So in the first section given, we identify A, the coefficient matrix, with all of the purchases of one industry in each column. So the coal industry has to purchase this amount of material from each of the other industries in order to produce $1 of its own product. This goes for electricity and also automobile. So this is the matrix A. The I matrix is the identity matrix, but the I matrix is basically saying that in order for the coal industry to produce $1 of its own product, it must purchase this amount of material from each industry. So the I matrix is following the same format as the A matrix. So now we move on to the demand matrix. The external demand in 1 week is $50,000 of coal, $75,000 of electricity, and $125,000 of automobile. So it's going to be a 3-by-1 matrix, where this is coal, electricity, and automobile. Now, since we have identified every variable, let's plug it into the equation. P equals the quantity I minus A inverse times D. So we have the identity matrix here, then we have the A matrix coefficient matrix here, then we have those inversed, and then we have it multiplied by the demand matrix. So when we subtract the identity matrix from the A matrix, we get this new matrix, which we can't call A, but I kind of did in this equation, but it's good to give it a new name, maybe A sub 1. So we have this new matrix A sub 1, and we have to invert it. So we follow the formula. The conjoined matrix AI, when you reduced row echelon form it, becomes the conjoined matrix of I and A inverse. So this is A, call it A sub 1, and the identity matrix I. Reduce row echelon form it, and then we have I and then A inverse. So A inverse is this matrix right here. Now we have P equals A inverse times the demand matrix. When we multiply these out following this format, 186 times 50,000 plus 102 over 27 times 75,000 plus 98 over 127 times 125,000. We do that for each column and row, and we're left with the coal industry produces $229,921.26 in 1 week. The electricity industry produces $437,795.28 in 1 week, and the automobile industry produces $237,401.57 in 1 week.